let's find those again. I believe we can number these by ones again. For finding my vertical asymptote, let the denominator of the denominator polynomial equal 0. I believe this factors 2x and x. The only way to get 3 is 3 and 1, and the signs are different. So I'm going to put a 3 here and a 1, 1x and 6x. I need a positive 6x and negative 1x to get a positive 5x. So here x equals 1/2 and x equals negative 3. In this case, there are 2 vertical asymptotes. And the other one will be at 1/2. So x equals 1/2, x equals negative 3. For a horizontal asymptote, the degree of the numerator is 1, the degree of the denominator is 2. Since 1 is less than 2, y equals 0 is my horizontal asymptote. So y equals 0 is a horizontal asymptote. Now, the rule is with the graphs that a graph can never cross a vertical asymptote. Will never cross a vertical asymptote. Sometimes the graph does cross the horizontal asymptote. Again, I've looked at these online. I graphed these and found out that on this side, over there, and before negative 3, tends to look something like this. This is a quick sketch from what I've looked up on my graphing calculator. But we have this horizontal asymptote here, and between these it's actually going to cross, and it'll come down, run a little bit like it's an asymptote, and then it comes over here and crosses down this way. Again, you may graph these on your graphing calculator and see what they really look like. This was a quick sketch. Average cost function of 25 plus 13x plus x squared over x is the daily average cost in hundreds of dollars for the production of Stanley golf carts, where x is equal to the number of golf carts produced. They ask to graph this function on the window negative 20 to 20 by negative 30 to 50, and ask, does the graph on part A have a horizontal asymptote? Well, grabbing the graphing calculator, and we would graph this. I have a representation here of what that would look like graphed. Wait a minute. I graph it, and here it is. The question is, does it have a horizontal asymptote? Well, no, it will not. And if you look at this equation, we've got 2x plus 13x plus x squared over x, this function. The degree of the numerator is higher than the degree of the denominator. It should not have a horizontal asymptote. It has what's called a slant asymptote. And if I drew it, it would be a line that looks something like that. That's a slant asymptote. Next, they ask us to graph it on a different window. And why would we change this window? Does the graph in the window part A or part B be a better model, and why? Well, let's see what that graph looks like also. Oh, now we only have it in this quadrant. X is positives and Y's are positive. Question, is the graph on part A a better model or part B? Actually, this, I don't think it should be part B, I think it should be part C. Is the better model. Why? Because we'll only be producing a positive number of golf carts and we want a profit, not a negative loss. So this graph is the better representation. Now they ask us to use that same function and use technology to find the minimum daily costs and the number of golf carts that gives that minimum daily cost. Well, this might look familiar. We have a picture of our graphing calculator, and they have found the minimum by left bound, right bound, found the minimum. It appears that minimum, X is 5, so 5 golf carts, and gives 23, I believe that's a profit of daily average profit of $2,300. I believe it was in hundreds. Yes, it was in hundreds. Okay, so this is the minimum daily average cost, producing 5 golf carts for a cost of $2,300. Now, slant asymptotes. If the degree of the numerator is one more than the degree of the denominator, its graph has a slant asymptote that we can find by the following method. We divide the numerator by the denominator, getting a linear function plus a rational expression with a constant numerator. That's basically our remainder. Observe the rational function found in step 1 as x approaches infinity or negative infinity, so the graph will have a slant asymptote, which is the graph of the linear function. Well, let's find a couple slant asymptotes. This is the function we saw, and we work with that daily cost function. If we basically take the numerator divided by the denominator. So let's take each of those terms in the numerator, divide it by the denominator. And we have 13x. So we have 25 over x, 13x over x, and x squared over x. Simplifying, this will be just a 13, and this will be just an x. And then we have plus that fraction. The remainder is 25. We're dividing by x. The slant asymptote is y equals x plus 13. Is this part of my solution when I divide? Now over here we have not just a single x in the numerator and the denominator. We have x minus 2. We want to take the numerator and divide it by that. Well, let's use synthetic division. In that case, we'll change the sign. X will be 2. We have 2x squared minus 3x plus 5. Dividing, bring down the 2. 2 times 2 is 4. Add is 1. Multiply is 2. And we'll get a 7. So this would be 2x plus 1 plus 7 over x minus 2, since it was really dividing by x minus 2. This then becomes our slant asymptote, y equals 2x plus 1.